Hello everyone out there. Yeah, this is Chanda Steven from Kampala DevOps Community. Yeah, welcome again to yet another year of insightful technical sessions. Yeah, and this is the first for this year. If you haven't attended any previous workshops we have had, yeah, you can visit our YouTube channel and get a recap of most of the sessions because every session we hold is recorded and uploaded. Yeah, I think we do it for the benefit of the community to further reference and further learn more in case you want to reference any topic previously discussed at any point in time. Yeah, once again, welcome to this session. Yeah, I'm really glad to have someone I've always been seeing on LinkedIn, Kazooba Lawrence, the man, I think he's what I would say the most active LinkedIn user I know. The man who is sharing the gist in tech, the latest updates, you know. And here we have him going to share with us a crucial topic that builds the fundamentals of almost, I would say, cloud computing, right? Which is Linux. So we're going to be diving into Linux administration and batch scripting. But before I dive in into that, I would like to introduce Kazooba Lawrence. He's a very experienced IT professional with a strong background in systems implementation, cybersecurity, IT support, and cloud computing. And if you doubt it, you're going to just observe it in this session. Yeah. Yeah. So without further ado, I would request Mr. Kazooba Lawrence, aka IT Fundi, to take over. Yes, IT Fundi is his YouTube channel. Yeah, you can check it out. He posts some nice nuggets, which are really insightful on a couple of things he learns and he wants to share with the public. So IT Fundi on YouTube, check him out. Yeah. Mr. Kazooba, please take over from here.
Okay, thank you so much for that very powerful introduction. I think being in IT is one of those nice things. You get to experience a lot and you never stop learning. I think for some other professions, you find someone might say, I've reached the pinnacle, I'm there, and so on. But as you can see, the coming of AI has introduced a new class of people, AI engineers and all these people. And you ask yourself, okay, who are these people? Where do they come from? And you find what skill sets are required. So it's consistently changing. But for today in particular, I was invited to talk about Linux administration, bash scripting. And as you can see, my name is Kazooba Lawrence. So in this session, we're going to be exploring a number of tools as we try to illustrate the principles that we're going to talk about. And so we'll be talking about, like I said, Linux and Bash, but we'll be using some tools. Ubuntu will be our go-to, and Proxmox. Ubuntu we're going to see what Ubuntu is if we don't know, and those who already know, kindly bear with us. Then Proxmox, we'll see a bit of Google Cloud. I'll show you a bit of some other tools that I have running, or OpenSense and Pi-hole, GitHub, and so on and so forth. So let's move on to the next slide. So what you were promised on the flyer, you were promised that you would see or learn basics and advanced Linux concepts. You were promised that you would see something about infrastructure security, essential hardening tips for secure Linux deployments. You were promised to see something about Bash, writing scripts that replace manual toil and minimize human error. Of course, computers remain as computers from that fundamental concept, GIGO, garbage in, garbage out. You write a script that is not well aligned, definitely it will perform what you've told it to do. It can cascade over into other things, but basically we live in a very nice time that validating scripts is not that hard. With the AI tools that we have, it doesn't make you inferior to use AI tools, but it's very important for you to actually understand the principles. We'll see a little bit of what happens when you actually, there's that very nice term called vibe coding. I've tried it out a bit and quite interesting, especially if you're dealing with a stack that you've not extensively worked on. You'll find that you will tell AI to correct things and it will, like, it's a very deep rabbit hole that you'll just go on. Some people call it a wild goose chase. You'll just continue spiraling on. We'll also look at DevOps, a bit of DevOps, because we're talking to the DevOps community here, leveraging scripting in CI/CD and cloud environments. A typical DevOps job listing would look something like this. I tried to get something that is summative and within maybe the range of most people. 2 to 5 years. Of course, there are people who, the plus accounts for those who are gurus, who have been in this field for more than 5 years plus. When you look at the key responsibilities, one that is highlighted there is automation and scripting. And basically, you're pushed to, you're told that, or you're required to understand how you can automate routine tasks, and you can see the different tools you're required to use. Basically, they are tools, but they stand as principles that, for example, can you programmatically using Python automate things? Can you write a script, which is also in a way sort of programming here and there, because some of the concepts like loops, variables, and so on still apply, or PowerShell. PowerShell is for Microsoft Windows. But you'll find that Windows now integrates also Windows subsystem for Linux, so you can enjoy Linux on Windows as well. As you can see, required skills, usually you see it's also still emphasized there that you need to know a bit of Python and Bash. So as you can see, it sometimes seems like DevOps is a whole mix-up of tools, yet it's on one end, if you watch some of the videos, if I know we've all watched some of those beginner videos, what is DevOps? You'll always find they're telling you it's a culture where operations integrate with development to deliver, and there is cyclic nature and so on. But before you get to all that, you look at the job posting, the aspect of culture, there is a little bit of it in methodologies, understanding Scrum and so on, but you find the majority, or if you look at all of it, it seems like they are tools. But it's just understanding the culture and understanding, because as you're learning these tools, what are you learning them for? You're learning them to make stuff easier. So we'll go to the first part, which is automation. And this is the first step of DevOps. Why are we saying this? Things like CI/CD, things like people who have done a bit of system administration have seen some of these things. Don't worry, there's a lot of wall of text, but I'm going to slide in the screen from time to time so that you can have a look at some other demo thing. Understand that the cloud basically is someone else's Linux computer. If you're using AWS, the EC2 instances, you'll see there are mainly, some are running Debian, some are running AWS. Linux in particular is their specific distro, lightweight. When you go to GitHub Actions and you're running those actions, you'll find the base image that is there most of the times is a Linux, not sort of distro, but slimmed out image. If you're setting up Docker containers, you'll that very statement that most of us are used to, which is setting up for you a base image that you're going to use to build on top. So you find Linux is almost everywhere. And those who are using Ubuntu in particular, I find it's much easier to, if you're using Ubuntu, you have the best of both worlds. You have a GUI to work with, but also you can run some other commands. Why would you prefer a desktop over a server which is headless? For a beginner, it's very nice that you can practice both things and have some of these utilities. But if you're going into a deployment, you want something to be as lightweight as possible, but also things like Ubuntu server are designed when they have stripped out a lot of, they call it bloatware in a way. Basically, you just have what is necessary for you to have it run. And if you need something, you intentionally install it, not like these desktop environments that come with KDE and GNOME and so on that are packed with a lot of things. And also, of course, it's a bit resource intensive. So Bash concepts we'll look at, we'll see from time to time how the aspect of making scripts executable, a bit of where are we supposed to store some of these. As you can see here, the recommendation is usually in the bin directory. We're going to see something about that because we're going to talk about Linux administration. We see running as root, when do you need to do that or when not to do that, and some automation tasks, some of the things that one of the things I experimented with, this is a link to GitHub where I was trying to do something. Here in particular, I had done some work with some people, and I had Docker containers on one machine. And I asked myself, okay, I don't want to waste my internet. I want to, it was a small bundle, so I wanted to move them from one machine to another. How would you do that? And of course, with help of AI and a bit of research, I was able to come up with some script that we can run. Some of you have heard of cron jobs, and yeah, you've heard of cron jobs. You're going to see how those work out, and also some automation tasks here and there. Some best practices. So when you're dealing with this, and this session is intended to direct you towards the side of that aspect of some tips and what to understand, because most of this information, if you want a comprehensive, let me say, bash scripting course, they have free YouTube channels like Learn Linux TV. That guy has some nice content there. You can actually, you can navigate through and see. It's a full course where he goes through the best practices and so on. But here, I just wanted to point your mind to look at where are you actually supposed to put these scripts. As you can see there, you can read for yourself. What paths you're supposed to be mindful of the path you're using. You're supposed to also know that for a bash script to run, it has to be executable, and we'll see something about those permissions. There is including the shebang, depending on how you want to pronounce that, and basically that is telling it's telling the interpreter interpreter that this is actually a bash script, and this is how you're supposed to execute it. It tells you, it gives it the modus operandi, basically, of how to execute that. Some other best practices, if you're writing bash scripts, please don't embed secrets there. It's, I think, something we already know. The Linux file system. So here we're transitioning to, we're going to see it side by side, because since we're running Ubuntu, we're going to see some of these things. So we are looking at, I'm going to show you that in a moment. So the basic file system, it's something you're supposed to understand, whether you're using Ubuntu server, which is headless, or if you're using, let me say, if you're using Debian, which has a GUI to it, or if you're using Ubuntu, or if you're using Arch or whatever. So Linux in particular, and before I move on from this, or before I explain this, I don't know if there is someone who can unmute and tell me the difference between a shell, a terminal, and a console. If someone is there, you could kindly tell me the difference, if you know the difference.
Mics are not enabled, but if someone knows, they can put up their hand, they can unmute.
Okay. If someone could tell us the difference between a shell, a terminal, and see, it would really be nice. Anyway, don't feel shy. You can post something in the chat. The difference between a shell, a terminal, and a console. And I know some people may be now going to Google and searching, but understanding that difference also gives you more context. Okay, someone is saying, are they different? The difference between a console, a terminal, and a shell. And someone is saying, are they different? They actually are. So the shell, so when you're running, let me say, when you talk about bash and Linux and so on, let me pull up something real quick here. Can you see the little terminal that I have put on the screen?
Yes.
Okay. So shell is like bash, yes. Okay, so what you're seeing right here, this is what they call a terminal, right? This window over here is what they call a terminal. When I do something like lsb, let's do that, lsb underscore release, which is related to bash call, this is a shell script, but in particular, I am running bash shell, which comes by default on Ubuntu, right? And then the console initially used to be the keyboard and the mouse and the screen, which is your integrated laptop screen or your external monitor and the Basically, they used to call it KVM, which is keyboard, video, and mouse, something like that. So the difference is a shell is the software or the program that is running. The terminal is the window in which you're running it, and the console is the machine onto which you're running it, if that makes sense. Okay, so we can move on to the Linux file system. So the Linux file system in particular has, if you've navigated around, I'm sure we've seen these different directories. And one of the reasons I asked that question is for you to just look at it and just see the different directories. Now Linux come and maybe also to push it a little bit further, we shall see the difference between Linux and the distros and so on as we try to move through that a bit quickly. So we're seeing here that you have these different directories. One of the best ways to learn this is to actually experiment with them. And the more you experiment with them, you actually get to learn what is under HC when you want to do some network configurations, if you want to do some configurations, temporary files mount, if you're removable media, if you're working with users. Sorry, that moved. Let's go back. The root directory and some best practices for that. Sorry, it's moving. Okay, that. So having understood this, we also have to appreciate that in Linux, everything is set up as a directory or something, everything is set up as a file in particular. That is why things like permissions, you have these file level permissions, you have these user level permissions, you have these groups and all these other concepts that are there, but all stem from you understanding the file system, regardless of the distro. For production, most of the times you'll find things like Debian, people who use Red Hat and so on, but mostly for the environments I've worked in, it's been Ubuntu. So Ubuntu server, sometimes a bit of the Debian images, but most of the time it's Ubuntu. So you can actually see the file system, and the challenge is for you to go out to, because you can't learn everything in this session, it's for you to actually go out and try to test it out and see how it works. So we're going to look at, so this was basically to just point you to the file system. We're going to see something about the intermediate aspect of system administration. And here is where the question, understanding that when you're speaking as someone who is working with Linux, Linux is the kernel in particular. You use different distributions that package the kernel as part of their, let me say, bundle. So when you are using Debian, Debian packages Linux, but also comes as what they call a distro. The other important thing there is also understand package management. So you'll see, for example, sudo apt-get and so on. Package management is what helps you to maintain software, add new things. These are things we've actually worked with. If you've remotely worked with Ubuntu, you'll find updating packages and so on. The apt is always very important. Apt install to install, dist upgrade if you want to do some upgrade of different software on the machine you're running. There's another concept of system CTL and service management. This we've used, and we're going to see when you're running, when you're working with, you've installed, let me say, a program like Nginx, and you want to see if it's running, or if you want to see if services are running basically on your machine. System CTL is one of those utilities. Understanding also when it comes to Linux, the reason why we've moved here to the intermediate side of things is because at least the LS and some of those things we usually interface with. But I want us to also appreciate that there are other concepts in there. For example, storage and LVM, partitioning disks, that in particular, understanding different file systems for Linux. Those who have worked with Windows know NTFS. But if you come to Linux, there's ext3, ext4, BTRFS, and these different file systems with their different paths for replications and snapshots and so on. Understanding networking, I'm going to show you that as well. Using some tools for monitoring top, htop, and so on to see, and also understanding processes, and also I talked about cron jobs. So let me just bring this up. So as part of the introductory slide, I mentioned that I work with Proxmox. Now this is for my home lab setup. One of the reasons why I set this up is because the way someone gets excited about phones and new stuff and new what, one of the things earlier on when I just started IT was I got to see some channels where people had home labs and what they were doing. Now this is far, excuse me, is far, far away from an enterprise setup, but it gets things done from my end. And why I wanted it in particular, yes, you can use things like CCNA and you understand networking and so on, but what this does to a different level is that it enables you to test out services. It gives you a safe, unlimited space to break things. And when you break them, you are able to sort them, give up on them, delete things. You basically can put your frustrations on your home lab and say, for example, because no one is going to penalize you for anything. And also, if you want to understand, for example, Prometheus and Grafana and all these different tools to how they monitor the network, how agents work and all that, Wazoo, CMs and all that, you can actually just come here, spin up a VM, dump it there and see how it works. But in particular for this session that we are having, what I wanted to show you is when you actually look at this setup, one thing that is consistent throughout it is that I'm using Proxmox, and one of the crucial things, like I talked about systems administration, is if you're, sorry, not systems, but Linux administration, it's not so far removed from understanding the normal basic concepts. There's a meme that usually goes around that before you jump to Kubernetes and Docker and everything else, before you go to VPCs and subnets and application load balancers and all those things, have you understood the fundamentals? Have you understood how to network? Have you understood how networks work? So even for this side of things, as you can see, how do you run these different services and what do those, for example, this is the machine that serves as my firewall. And on this, my firewall is an open source VM that is running on this. And that VM is it's a Ubuntu server, which is running this. And basically, as you install this, actually, sorry, it's not a Ubuntu server, it is OpenBSD. OpenBSD is another distribution or flavor of Linux. So OpenBSD is what is behind tools like pfSense. So OpenSense is just a fork, a spin-off that they picked and improved, has a slightly better GUI, a bit more modern, looks better. Of course, pfSense still has a lot of functionality, but yeah, that's subject to debate and yeah, a lot of talk. But when you set up your own lab, your own VM, some people use VirtualBox and so on, but I found that Proxmox gives you a bit more room for you to actually set up close to some enterprise level things and understand some enterprise level concepts. So as you can see here, like I said, different services running. I think we've gotten enough time to see that. So let me pull up this environment over here. Just put it up here. Just one moment, let me open up these slides elsewhere. Let's open them up elsewhere and have a different view here. Okay. So I talked about package management. I don't know. Add the thing there. I talked about package management that we're going to see. I wanted to show you in particular. Here we talked about, let's bring this up shortly. We talked about storage management because at least this we have an idea. We're going to see this in a separate demo, but as you can see, for example, partition management. Let me bring up. So I also run Proxmox backup server, and what that does, it enables me to test out also the aspect of understanding some of these things. For example, if you want to work with things like LVM and partitioning, the way you do disk partitions in Windows, for those who have worked with it, you'll find also in Proxmox, you're able to see this concept live. Like I have my SSD, which is around, I think it's around 500 GB, but this, it's split up into other things. But you can see that this disk is partitioned into 3 things. And you can actually see we're using LVM. And what that does, the promise here is that it makes it flexible and easy to work with. And also, you can also appreciate the fact that here, the reason why home lab is important, those who work in cloud and so on will also appreciate, will see where you can play around also with cloud instances. But here you can actually split so if this thing fails, let me say, for example, I don't have much to lose. It's just something I use for experimentation, and I can repurpose hardware as I desire, depending on the requirement. I just keep on playing around with it. In Linux, in file systems, you'll hear of things like ZFS and so on. But in particular here, I wanted to demonstrate to you that you can actually see here, when you talk about LVM, Proxmox is based on Debian. So you can actually see directly. Someone said, if you can get a Proxmox, with help in learning. Okay. So if you see this, you can actually see it in action, that you have your SSD, it can actually be partitioned, and you see it's working with LVM. What this also does is, like I said, I'm also running some other VMs. When you want to understand, because when storage and backup usually go together, there are different ways of backing up. When we talk about storage management, this is storage management, but also backing up as a part of network administration, of Linux administration. One of the tools you can work with, some people the setting up of cron jobs and rsync and so on, depending on the environment. Of course, some Proxmox is a bit heavy. But when you actually understand this, when you're moving to things like VMware, if you're using other platforms, you understand how these concepts are in the real world and in the enterprise setting. If you're working with, let me say, for example, you have your Linux VPS on Hostinger or whatever provider that you have, you can basically put, you can set a cron job to export, let me say, to push your SQL dump somewhere else. You can set up, there are various ways of doing it. But in particular, I really explore more the enterprise side. Not, of course, there is the hustler way, which also some enterprises use, but there are some other concepts you will not get if you just do it that way. There are things like replication and so on. For that part, I wanted to show you also a little bit quickly when it comes to, let me just see this VM here. This one was shut down. Okay, let me just see. So for example, here this is the terminal that is displaying, or the console. You can, of course, there are also virtual consoles. Like I said, the console is like the machine, but this is like a virtual console. And if you see here, you'll see it's giving you all these features that you can work with and so on. So in particular for LVM, you can also see things like file systems. You see something like ext4 that is being used at the root of this file. You can see things like swap and so on. And the intention of this always is to just know that you can work around with things, break things, set up things, and so on. Yeah. So that move, let's see. The other bit I wanted to show you was about networking. So when you're talking about, so this is Proxmox virtual environment. Let me see. So here you see something like a shell, and there are different directories, like we had said. We had talked about etc. Let's just see if this one did to, sorry. So cd etc ls, and here we can see this, I think, networks interfaces, one of those. So we can see So here I wanted to just show you. Okay, let me just give the list of it, and then you can just see that. So here you can see that when you look at this file system, now we're under etc. There are a lot of things, but this is specific to Proxmox. You'll see things that are set up like cron jobs. You'll see things that are set up like the FS tab. You'll see things that are set up in particular init ram FS. This little utility here that when you're booting up, it enables to sort of create like a file to test out as the system is booting, putting it very simply. But ideally, I just wanted to show you that the limits to this are so many. There are no limits to what you can actually do with this. Let me just do that. Minimize. I also wanted to demonstrate, for example, when I talked about the home lab, one thing now lost in the windows I had put up. So one thing about the home lab is, as you can see, you get to understand some of the, now this is slightly outside Linux, but also you can just take it for what it is. You can see that in this particular setup, you can understand network speeds. So when you're called to, let me say you're working with a Linux machine, your Linux machine communicates over the network. When even if you're in the cloud, understanding how these things work, for example, you will understand why having a direct VPN connection to site versus a dedicated thing like I think it's Azure Connect in particular, one where they tell you, for example, that one is limited in terms of bandwidth to 1 gigabit, and another one can expand because it's a dedicated link and so on and so forth. When you're actually working in administration, understanding these environments, for example, you can try to identify bottlenecks. Now, in particular, this is a very small 5-port switch, but it supports gigabit. And what that is able to do, it gives me speeds that are, as you can see right down here, between 90 Mbps and 100 Mbps, or sorry, MBS, megabytes per second on the network side. And I'm able to, let me show you, for example, if I want to, let me see if I can do that, back up a machine real quick here. You will see how quickly, and does not waste much time, we'll be moving on to other things. But you can see here, let me say I want to back up OpenSense. I already set up, so Proxmox virtual environment has a dedicated server that connects to the backup server, like I've said. So Proxmox comes with different capabilities. Let me say it gives you a feature for which is a separate server for backing up. It gives you a separate feature. Now this one is a backup server. It also gives you a virtual environment where you can actually run your things, and you can create clusters and things like that. High availability, where you have things like polling and things, basically setting them up. This is in a local setting. Of course, the cloud covers up a lot of things. You will not see things like RAID and so on. They'll just tell you automatic replication, availability zones, and all that. But here you understand that what a snapshot is, replication, and so on. I know most of us in the cloud setting, that is easy to do, but here it's just challenging yourself a bit extra. So let me just back up this machine, and it's around 32 GB. So let me back it up. And like I said, when you're running gigabit, you actually can see, of course, Linux, when it's maybe a little bit of a nugget there, when you're running on Linux doesn't have a when it's counting these file sizes, it uses something called megabytes. I think it's megabytes with that. That's why it's an MI. It's actually a different calibration of the file sizes. But I want you to see how quickly over a gigabit link, and this is a small setup, how it's actually to push speeds up to that kind of speed of, you can see how fast it can actually push things. Now, this is on a local setup, like I have showed you. And you can see that that's why I kept on marking those links there, the way they are marked. Let me just put this aside and also go back to what we're talking about. Setting up cron jobs. So cron jobs, as I had showed you at the start, we have an idea of what cron jobs are. But what I wanted us to also see is how some of these things apply even in normal administration. Let me say working with firewalls is something that we can see, and you'll appreciate that, for example, so this is OpenSense, and it's also running on Proxmox. And as you can see, basically exposing normal simple network things. Like I said, it's not something hosting any important stuff. I have a file server, which is not part of this, that is separate from maybe media and videos and so on. But this is just a home lab. So basically it's also free to, it's okay to see if it were a video, blur out stuff and so on, but yeah. So here, when you look at things like cron jobs, now this is now the reason why I didn't want to go the normal route of showing you this is a cron job and so on. Even in OpenBSD, which I said is the basis for this as a distro, you can actually set up cron jobs, and you can see, you can set them to run every minute, every hour, every day of the month, particular months and particular times of the day, and it performs a different action. So how is this related? I wanted to, let me just show you something. Go back through the slides. If you look at the bottom here, where cron jobs are, you can set up, for example, a cron job to run. Like I said, there are minutes, days, hours, and months, and so on. And it runs a particular script at a particular time to perform a particular action. So we're going to see how those scripts look like. But let me just see if this is done backing up. Okay, let's go back here. I have quite a mouthful of stuff. That moment. Let's see here. Oh, this is the beauty with demos. So it has actually failed at 78. But I want you to see how quickly this had backed up 25 GB in actually 2 minutes. And that's quite some good speed. And that's at gigabit level. You have 2.5 gigabit, 10 gigabit, and so on. Okay. So the other thing is about understanding processes and cron jobs. Yeah. So some of the advanced things are understanding firewalls, system hardening, advanced bash scripts, and so on, virtualization. Maybe I'll just also talk about, most of us are very, could be conversant with Docker and Docker containers, but also there is another nice thing that now Docker containers focus at application level, and also it's basically sort of OS level, but it's just packaging the application with necessary files for it to run. But one of the other cool things that Proxmox gives you are what they call Linux containers. And Linux containers also, so these also virtualize but make for you a full OS in a sense. And Ubuntu Server or Debian are the ones that create sort of images, and it helps you to also do some virtualization. It's a bit heavier than Docker containers. That's why Docker containers are very popular, but it's something that you can look at for sake of curiosity. Okay, so bash script. I know all of us have been waiting for some of these things. I just wanted, let me just see if I can get a script that I can demo for you here. Script here. So when you're talking about bash, these are things you can find on the internet, read, evaluation, print, and so on. But what when we are running, like I said, the difference between a shell, a terminal, a console, Ubuntu ships directly with bash in terminal that we usually get exposed to. And these are things that we've worked with. We've worked with listing directories. Like this is part of those things of bash that we can use. So you can also do like ls. Let me say, if you do lsl, these are things we've seen. The long listing. When this is listed out the way it is, you're able to see, let me say you have data represented a certain way. You have the users, the groups, and outsiders, but you can also see these commands, ls, let me say -la, then H, making it human readable. As you can see now, we've shifted from using this kind of layout to telling you it's in KBs because of the H flag that has been added. Understanding also directories, understanding system links. Those are some of those other concepts that are in there in Linux that you can look at. Understanding variables. For those who have been exposed a little bit to things like Python, you've seen or you've appreciated Python or any other programming language. Basically, you've appreciated variables and how powerful they are and what they can do. But also these variables come in handy when you're working with secrets, because one of the things that was promised is a bit of hardening tips to understand in production environments, how do you store some of these secrets? Or let me say your credentials. Let me say you have your IP address, public IP address, you have your API keys, you have, let me say, your API keys, passwords, usernames, and how do you securely store this? And how can they get injected at runtime as you're deploying an application? See some of that. I think at the top of most scripts, let me pull up a script and see if I can bring it halfway here. Let's see if it can come. It's covered everything. Just see if it can be there somehow. So you see things like understanding, let me say when you're setting up, when you're using something like an output file. So you see you can setting, I want to talk about the shebang bit. This tells the interpreter that it tells Bash how to actually read the script, but the only way to do that is if it has been made executable. And we'll see a little bit about that in the permission section. But here you're seeing, when you write your Bash script, this is very crucial to put it at the top. Now this, set E is, I think it's called error exit, I think. So sometimes you don't want the script to continue, like I talked about at the start. When you write a script that performs something and it goes out of hand, it will basically do that very well. And that's where Bash comes in handy, that if you want to run something real quick, you can say, and it works very well. And also for things, if they are nested, let me say you want to perform actions and they are nested, it's very quick. It does, it executes quite fast. But the other important bit is, let me say in case an error happens, this flag here helps you to exit. So there are different flags you can add. There's O, there's, I think, U, there are different flags, and that can help it exit if an error occurs or something of that sort. Let me say something goes amiss. But this is where you start weighing in your balances when you understand. So when you're working with your script, and let me say, if it gets a problem, maybe it crashes or something, where is the check? You can write other scripts to check this script, but that's where tools like Ansible for some automations come really in handy. That Ansible has a term called idempotency. It's a very fancy word, but basically it means something can be done repeatably. Let me say if you run an update, when you're running the script or the playbook again, it will check and see. It sort of does a simulation of its own, or a check to verify and see if the changes are already there or already existent. Therefore, it will always ensure that if it runs, it will perform the same thing exactly without going amiss. But if you run a Bash script, and let me say midway it failed the previous run, when you run it again, what is going to happen is that you'll see it will start afresh, and then there will be conflicts, and then it can cascade. And we'll see a concept there that in DevOps, usually when you're let me say troubleshooting, unless you want a forensic kind of thing that you're checking the error logs or you're checking to see what happened, most of the times, if an instance gets an error, you usually want to spin it up again so that you start from a fresh page and you're able to run things cleanly. We'll see something about redirecting input and pipes. For example, here, pipes are quite interesting. That, let me say if I do ls, and let me say I do ls, and do that. Makes it human readable. Then you set a pipe. So a pipe is sort of, you're getting the input of one and directing it into another command. Let me say grep. So grep is sort of like a search. And you'll forgive me for not going directly into this is what grep does and so on and so forth. This is basically to trigger your mind of the possibilities and what you can actually go and test out. And let me just see here. Let me say something like SSH. So in this flag, ls is listing the files. L means that it's long. If you don't put the L, you find the files or the output of ls is sort of like on a line, a straight line, like a paragraph kind of setting. Let's see if I can do that. Yeah, so in sort of a paragraph setting, let me remove the L. And you see it's not really something interesting to look at. But if you do it this way, let me just remove the grep. You see this is better to look at. So the LA, there is what they call long listing. Then HMake is sort of the way I got it some time back was human readable so that you can see the file sizes in a nice way. And the A is basically listing all so that you can also see the hidden files that are in that directory. And these are sort of the basics as you look at them. But the grep, so here you're seeing that I am listing everything, and then the pipe is basically saying, I am passing that output from ls, LHA to grep, and grep is sort of like a search utility. Yes, you're buying airtime. I'm saying grep is like when you're buying airtime on your MTN line, and so you buy the safe. Okay, thanks for that one. Yeah, so basically you can see what it actually can go into and what it can do, right? And it can, so when we search for SSH, you see it's finding, so SSH usually is a hidden directory, but it's able to find it. Yeah. Let me just move on to just pull this out of the way. So you'll also see if you've done, if you've worked a bit with some of these other programming languages, things like if-else, things like, so because this returns, for example, a Boolean. So you're saying if this is true, so A is a sort of variable, and they say it's equal to B, then perform something. Fi is the way you have if else, and then yeah, so if else, and then there is the final way the loop is terminated. For different languages, let me say if you're using a switch statement, there are blocks like finally. There are things, if you're doing some error handling and try-catch blocks and so on. So you want to set up, now the try-catch blocks are something different, but when you're setting up loops, if else kind of setup, what happens if the first part is not true, then perform this. You can do a lot of things like do of sorts, parameters, some of these things. So this is a script that I worked on. And basically what it was to do was to, as you can see here, it's available on GitHub. I also wanted to have something published out there in case questions come out. But you can see you have the bit of echoing to try to sort of display some kind of message on the screen or in the terminal. Sorry for using the word screen. When you use the word terminal, it seems cooler. Okay? So yeah, you're able to set up some variables. You can see some of these pipes in a more complex way. Right, someone has also added there something in the comments. So this looks through. Basically, the intention of this was to look through my machine that has these Docker images. I wanted to check them out, look at them based on different tags. And if those tags are there, I also want to look at images that are dangling, basically those that are not untagged or are not associated with any tags. And these in particular would be, I put up sort of this loop to export them into a table, and that table would be sent over my local network using the awk command. So this is a very powerful command as well for recognizing patterns. It's very useful in things like CSVs, looking at log files. And as that works, it would basically, so this also works, it needs a support of Python 3. And when you run that, it's able to, you see things like the get command or wget command. pushing it over the network from one machine to another. Now, the question is at the end, was this successful? Somehow it worked, but some of the images failed to work. And basically also went for version 2 to see progress indicators and so on and so forth. Yeah. Just to interest you in what Bash can do from some of the things I've tried out. Things like process substitution and let me just move on quickly to, I've used around almost an hour. Moving on to hardening and security. Like I said, Linux, most everything basically is a file. And if you get the permissions wrong, everything. When it comes to security and hardening, in line with Linux and Bash, understanding, like I said, I mentioned something at the start of which directory. Is it in sbin? Is it in bin? When you're setting it to be executable, under which user is that being done? Is the user and also here in particular, you're looking at understanding when I showed you that along this listing here. As you can see what these components mean, when you see a D, meaning it's a directory, when you see a hyphen, meaning that it's in particular a regular file, when you see that it's a symbolic link, unfortunately, I don't have symbolic links here. They are quite interesting to work with. Sometimes when you're doing some installations, there are times where, let me say, you mess up your permissions and your, I think, I'll show you a symbolic link when we go to Nginx and we're seeing how that plays out. And basically, it sort of creates a sort of link. And yeah, so understanding what RW and RWX means being executable. So these are things we've seen, but the purpose of this session still is to get you curious to go and actually look out and see, okay, what exactly does this mean? How does it tie into what I'm doing? And remember, if you're working as a DevOps engineer, person, systems administrator, even in cybersecurity, if you're a forensics person, if you're looking at this, you're understanding, okay, what permissions are on this folder? What permissions does this user have? If you find a user in the system with particular, let me say they have the ability to execute everything, how is that working? You find actually these things tie into most of the other concepts because it's security related. One of the nice ones I also talked about, wanted to look up, that we're going to look at is about secrets. But also there are other things that are common when it comes to hardening, running updates. We talked about package managers, MFA for accounts, let me say cloud accounts that support that. There is zero trust, setting up identities and all that. It becomes a bit more complicated. Understand. The other important bit is architecting. Let me show you just something small. This is very elementary. I know some experts that are here will laugh, but when you actually look at this setup, one of the things that I had a problem with is that initially everything used to connect to this router. So what would happen is there's a group that we're in, an IT group, and I mentioned that I have a complicated relationship with ISPs. So I have canal box, I have, so a canal box offer will come and I take that, there's MTN and then there's Airtel and so on. So I had a challenge that whenever my setup was always tied to the particular router that I was using. So if, and a router like Canal Box does not allow editing some of those changes, the network configs, you can't change the subnets, you can't change anything. So it was really a pain. And what would happen is that whenever I would remove that, I used to have to go to each of these machines, in particular to change those static IP. And I thought to myself, I can do it better by just introducing this switch and removing that the bit of DHCP and of course the DNS that I use is on Pi-hole. By moving that to this machine, I totally separated everything from the ISP. It's only the one that gets DHCP from that machine. So basically my whole network setup is isolated from this. The reason why I'm showing you that is that when it comes to architecting, whenever you architect something well in AWS, when you're doing the associate exam, they're called principles for architecting. excellence, resilience, performance, and so on. These concepts only come when you understand things to setting up things in terms of hardening, security, performance, and so on, is to understand, don't architect things well, things can cascade. Even when you're setting up your files, when you're setting up your users, when you're developing that application, how are the files managed? Yes, actually, when you're setting up for tools, I've interacted a bit with Spring Boot or with other, I think even other things like React and so on, these other frameworks. When you're setting up the files, they have to be a certain way. If you jumble it up, there are configurations, of course, that you can alter, but you always have to understand that it's designed in a it's supposed to be designed in a certain way, and it's easy to troubleshoot it. Having that map of the network makes stuff easier. Logging and remediation, of course, that is those who, if you've done some Grafana, Prometheus, net data, and maybe I'll just show you something simple. It's not enterprise level, but at least you can appreciate the concept. When you look at why understanding also, even if you're working with Linux or whatever, understanding these machines, there are different commands like top and htop. I didn't want to go. People can get for themselves htop. I think, okay, this is not, okay, it's, I think I have top. See if that, so you can see, this is really not so, okay, it's user-friendly in a way, but not so user-friendly. We are all talking about Linux and all. But if you see the other tools that can help you do it better, let me show you, for example, in this Proxmox setup, if I have a, let me say if you can see, I can always go to my disks and storage. You can see LVM still, this concept here in Linux. You can actually see how easy it is to understand, okay, I'm almost out of storage. It's easy to understand, but all this is when you architect it, you monitor, you log. These are concepts that cut across even when it comes to the setups, right? Move real quick. So handling secrets. Now, when you're deploying, this is an example I was able to get about deploying. Now, these are 2 bash scripts, right? And this bit down here is exporting this as an environment variable. That's another concept you can look at. Let me say you're running your Linux machine or server where you just you set an environment variable like that. Imagine if this is a bash script and you push this to GitHub. You've seen, we've had stories of people pushing some of these keys, even to GitHub, and actually have them exposed. Yet they are, if I'm not mistaken, there are some bots that are usually crawling, looking at these sites and just seeing if there is anything exposed. Automated tasks that are set up by some hackers, sometimes some security experts, to see what has leaked and what hasn't. But you can see here when we set it up this way, now here we're that it's part of the environment. And how does that work? I set up here a project sometime back. I was experimenting with DC tools and CI/CD in a small sense, but you can see under this particular repository, under the settings, you're given secrets and variables, and you're able to set up environment variables or even repository secrets. So as you can see, it's giving you the key, and it's sort of key value that you don't need to let me just show you here. You don't need to put DB password, and then what it is here. It will give you an option to put DB password and then the password itself. And then as you're operating, it will inject it. In the action, as we're going to see. I'm going to show you some of those demos in a bit. We talk about the wall of shame. So here, it seems like it's impossible to do something simple like this. That's why I said architecting is very important. When you understand the best practices, you have internal processes. Those who have worked in IT environments extensive, whether it's operations, cybersecurity, whatever, a place that does not have some of these guidelines is a nightmare to work with, because you will want to do something that is expected. Actually, one of the times you see those loopholes is when auditors come. Of course, people have come up with playbooks that when auditors come, this is the check, these are the, because they come with a checklist. So they keep on checking everything. But when they come into a place, when you actually have these processes set up, how do you actually handle secrets? Who handles them? How do you set up your Git? How do you set up? Is there two-factor authentication and so on? But secrets are also the bit that we are focusing on here in particular. So an Uber engineer, this was around 2016, I think 2016, 2018, around there, pushed keys and they were able to make transactions, they were able to pick data, they were able to do a lot of things. Uber paid some ransom money, but they ended up settling at a huge. We've seen something recently, CloudBot, OpenFlow, where people, we are living in a time of vibe coding. I've also done some of these things, but of course, you do them as it's nice to practice before you do a production deployment on your own, whether it's Lovable, Windsurf, all these tools that exist. You can just try out, let's say you have a demo account or a trial account. Can you actually try to analyze the security? If you ask them, can you make some commits to thing? But people hand over these keys. They just so as they're doing the vibe coding, there's a prompt. It says you can read what's on the screen, but you can so it brings the prompt. It says, give me this key, you add it. Give me this key, you add it. And then when you're making a commit to GitHub, you find this thing didn't actually put them in a .m file. I'll show you. Let me just see if I can grab that real quick. Yeah,
Lawrence,
so here,
something interesting. Yeah.
Yes.
Yeah. So well, with this, I think one can I think I can testify that I've seen AWS they continuously scan repos for any access keys, and if they find any access key, they deactivate your account. They send you warnings. So I think these days they took it in a level higher to avoid something like that similar that happened to Uber. I think, yeah, as you shared, they have something scanning each repo to ensure that no keys are exposed in code bases on public GitHub.
Okay. Thank you so much. So nice and insightful. So you can see, so here is one of the places I interacted with some of their repos. And this is a public repo. And you see here they put an M file, but this is an open source thing, so you can change it. So the question is when you're deploying to production, right? And someone knows, let me say you're doing an ozone, this is an HIS, a health information system that is based on OpenMRS and other tools like Odoo. I think we've heard of Odoo, ERP Next, those different things. But you can see here, of course, it's an open source thing and it's okay. They put this out if someone wants to try it out. But if someone, let me say, gets this software and wants to this and they just leave it to run as default. One of the things that that is done when you're deploying to production is what happens. Someone will get the particular env with the right credentials, and then he will put it in this directory so that so that it's able to run in production very well. But if you get just things by default and paste them, you find you're using, let me say if it's an AWS bucket or whatever you're using, you don't change any parameters, you just use the things as they are. Look at the passwords, the users, look at some passwords like this. So the important bit here is just to appreciate that handling secrets in the Linux environment is also very critical. Beyond permissions, so one of the things we've worked with Docker, so like I mentioned, I mentioned that in passing, immutable infrastructure. So when you're setting up, let me say server and things crash, that's why the best practices for advanced DevOps settings is you have a dev server, a staging server, then a production server. So you usually the dev server is destroyed and set up and destroyed and set up. So when a release is made, you put it on the let me say particular version release, you put it on the staging server, and let me say you have, of course there are other ways of doing it, but you can use that as a user acceptance testing. People come up and test that release and see if there are problems from the QA people, but also the client, to see so that you can sign off on requirements and so on. But here you so when you're dealing when you're setting up, this principle here says specifically, let me say for the dev server, and if you're not doing any forensics, you don't want to wipe a server yet you've not analyzed what was the cause of it failing. But what we are saying is that instead of trying to fix something that is already dead, you want to wipe it out and set it up afresh. Of course, there are other principles of backing up the database. If it's a monolith, let me say it's set up as a monolith, you want to, maybe there are parameters that you want to back up and understand where they are and all that. But we always want to ensure that we have something clean so that someone doesn't persist. There are stages, I think in cybersecurity, there are stages for compromise or something like that. There's a nice word they use, where someone does reconnaissance, then he gets a foothold, then he performs something or maintains that foothold, cleans his tracks and so on. So you don't want someone to permanently be in your system. This is one of the nice things to do, but of course it has its precautions that are to be taken. Using minimal distros or distroless images, like you can see, usually use Debian 12, for example, here. And what that does is that it sort of cuts off access to certain tools. But also the downside to it is if you need a certain tool, you have to install it. But it's better to increment, you're sort of having a list, a minimal setup where you have fewer, only what you need. Some of the other best practices when you're setting up IPs, this is when you're doing your administration of those Linux systems online. So here I set up something in Google Cloud Run. I was using, so Google Cloud Run is similar to, I was testing it out. I used to have worked with AWS Lambda, but I had not worked with this. So I wanted to test myself and work out with it. And yeah, so the setup was, so basically one of the reasons why I wanted to recommend this is that you have like a $300 credit that you can actually go and run a VM on, run Cloud Run, run these services. And how this is different from a VM is that it only runs when you receive visitors or when it is triggered to perform a certain action, lightly putting it. So here what I had set up is, I set up a Docker container with a script, and it was supposed to be worked on by Google Cloud Run, where you set the source and you sort of deploy it. I wanted to do a live demo, but it sort of it kept failing for some aspects. And of course, because of time, I'm already past 1 hour. But you can see here setting up we have our file here with the same things. You have setting up ports, the shebang at the top, icon, which is to sort of which is to display message in the terminal. You can see setting up some of those variables in there. Now you can see a while loop there, which while true. Of course, it's very important to understand that. I think I forget the name of that, where you would run a loop and it would run infinitely, but you also have to be very keen as you're setting up some of these loops. Like I said, garbage in, garbage out. And what this was to do, it was particularly to display a short message in the terminal, but I wanted to use something like netcat, which would try to pass on this output of the file, because it was pasting it to health report.txt, and so that I could get it in the terminal. So running this image, you can see here still, the reason why we're using apt-get and update and so on is because Debian, this is similar to Ubuntu, because Ubuntu is a Debian-based distro. And it also, so the other one that is also Debian-based is also Proxmox is Debian-based, and also Kali Linux. So the three tools some of the tools I like using the most are within almost the same ecosystem. It's the equivalent of having a full stack developer in JavaScript. Like you have your front end in JavaScript, you have your back end in JavaScript. Like basically you you have arrived. So I also like Debian-based things because the commands are more or less the same. Those who have worked with Docker have seen. So when you look at the run command, you're basically setting this up as an executable script. But like I said, there are best practices behind. You don't set up a user, don't run users as root. You set up another user on the side to work with versus using root, exposing and also running the script. And basically, as you can see, it was hosted on this, and it was displaying this small status thing. So this is the last bit for this presentation. And here, what I was intending to set up was, so also the nice thing here about Cloud Run is that it costs 0 if no one visits. So they're only triggered based on certain events. Some are similar. Of course, there are better explanations, but high level at that point. Also, so here what we are going to look at is where we do a git push, bash script runs, and it automatically logs into an instance and also does some updates. Let me just, so the setup is something like this. We set up, we put Nginx on our VM in Google Cloud. We give permission to the user to have some read-write access. We generate an SSH key. And this is a utility that Bash provides where you can generate a private key, public key. And then we put, so this, we move this to a trusted list on Ubuntu. There's in Debian or Ubuntu, you have an SSH trusted list. We add the public key and make it accessible, that trusted lists. Then we also go to our GitHub. We put some of these credentials there plus the user, and then we have our pipeline run, right? So let me just show that to you real quick, and we'll be well on our way for questions. Let's get to that. Just a moment. Let me just navigate to this. Just, so just a moment as I navigate to that. Just move this here. Oh, okay, it's actually here. Let me just, that is, just one moment. So, so this is one of the nice things about using Google Cloud is that your identity can be your email address, so it helps sort of works on it quickly. So we have our VM here, and this is running on a public IP address. Let me just see. So you get this $300 credit, and it's for 90 days, although I had slacked a bit. I was a bit busy. I hadn't used it extensively. Set up this machine yesterday. In the administration side, it's not related really to Linux, but understanding billing and as being part of the principles of system architecture is also cost optimization and cost effectiveness. Very critical to understand. Whenever you're running stuff, always look at which services are running, whether it's AWS, Azure, and so on. Look at the I think we've seen it when we are, one of the places where that is very nice is when you're using some of these platforms for vibe coding. They tell you have 50 prompts and you keep checking. You don't want to waste any prompt. You keep checking, looking at your prompts and so on. If they tell you it has extended context and so on, you always want to have an eye on your bill and have an eye on the credits that you have left. So you're looking at normal VM, you just come to Google Cloud. This is available to anyone. So you can do Google Cloud Run, but also you can use, as you can also see, this is something I put in the cloud, and this is also Debian based. Let me just see if I can list this. We'll do the final demo. Yeah, it's yes, we'll connect to this. One of the nice things about these cloud providers is if you have multiple emails, you're able to experiment and test. Really, you can test out and see. Let's be. This is starting to become stubborn, but just saying into that. C underscore. So as you can see, this is a VM. I set it up in particular, and it's running Ubuntu. So same thing, you actually have this. So if you have done this locally or in your home lab, you're able to actually practice this as well in the cloud. It's just maybe to inspire, to also encourage others to try out different things. So when you set up this VM, things like SSH, and also because when you set this up, let me say, and you're working with Nginx, you'll have to work with firewalls and ensure that one of the nice things about having AI is that whenever you get an error, one of the powerful skills of administrators, developers, and so on, other than being able to set up things, it's also being able to debug them really quickly. And that's from log analysis, looking at the logs, understanding them. Now, AI gives you a lot of more context to copy paste that. And as you can see here, Google is offering that Gemini CLI is available. So you can actually troubleshoot things quicker, and it gives you more context because this is trained on Google data itself. So it understands, like we always should appreciate, human judgment is also very key, but understanding that this will give you context is also important. That it's a tool you can utilize. So setting up this VM, it has an internal IP and an external IP. This is the one we're going to use to access it. And then, like I had explained here, let me just show you those slides again. So we set up the machine, we install Nginx, put the SSH keys in authorized list. That's how authorized list. Putting these in the GitHub secrets, you're going to see that. And then setting up a deploy.yaml file. Also understanding YAML is very important, because when you're setting up network configs for Proxmox in particular, it's through YAML. And if you've worked with Python, if your indenting is off, you really struggle to run your scripts. But YAML is also very sensitive to that. But also online, there are tools that can validate YAML. But always remember, if you're pasting any of your scripts online and you're using some of these tools and your keys are there, there is a high risk. They will promise you, someone mentioned that if you're not paying for something, yeah, you are the product. So if you put your keys there and you paste them, you should be very careful. You may find your things being used elsewhere. So only paste what you can afford, or you can strip that out of the script, paste it in a YAML validator, and then they're just simple utility tools online. Basically, nowadays there are online tools for almost everything, but the aspect of data, of privacy and security is a whole different ballgame. So having generated the SSH key, you can come to, and just duplicate this. You come to, okay, so you come to settings. Let's check here and see that I'm not alone. People are still there. Okay. So the last bit is you come to settings, you're able to set up, the SSH key, the user that you have set up. Like we mentioned, don't use root. What Google Cloud does is that it takes the prefix of your email address. Let me say if that's my email address. It takes the prefix. I know this will be public, but yeah. So you take the prefix, and you're able to it utilizes it as utilizes it as the user, and then you're able to run. So here, okay, someone is still there. Okay, so here, This is a very simple script. So we have our machine live. This is the external IP address, and when you try to set this up, you will find the reason why I didn't in particular go into it is because there's a firewall component and some allowing HTTP traffic. Remember, Nginx runs on port 8080. Some of those things, as you actually work with this, that's where the learning is not showing you. There are tutorials that show you how to overcome that, but I wanted us to get inspired to look at Google Cloud and actually go there and try to set these things up and see how it pans out, even at least even if it's for today. So here, I have this script here, and at the start, I give it a name. So here, this is in particular, GitHub Actions. So think about them as a way of configuring a certain trigger from your code to a server directly using tools like rsync and SSH, where you give, so the key we provided gives it SSH access, but also we set up, we give it a sort of permission to log into this machine and actually modify the HTML file. Usually when you set up Nginx, it tells you at the start, welcome Nginx and all that. But here we're going to utilize this component here on line 19 of script, where we generate a script. Now we're going to see what this means. And I think I'll first show you that before I show you how it demos out. So here, we name the script and we are saying the action is that when we push something to the main branch, this is what we want you to do. The job is to deploy. It's running on this image. So you still see this is Linux in the cloud. The steps is that checking out, you check out, and these are some of those utilities that are built in that we utilize. And this one is basically to copy your code and put it in a sort of, I think they use the word runner. So that your code can be able, so that they can work with your code to actually push it. SSH, you SSH into it. It's also a utility that you don't have to build this. These come. And then you say, now you see how the secrets are managed. No one can see what is in here. They are injected at runtime. And then my script, we generate an HTML form directly into this. This is where you have the index.html file where you say welcome and so on. So we are pasting there this. So I'm going to modify something little. And as demos always work, pray that it works out. Let me say Kazooba B.
It will. No demo fever today.
Okay. Let me just edit this. Let's see how this works. And let's do 2026. So here, like I said, the job is saying that when I commit changes, none of the beautiful things about AI is that writing commit messages used to be an issue, but yeah, sometimes it just reads through and you can see how stuff is getting nicer by the minute. So we are committing directly. So if we can specify a branch that whenever someone makes a pull request and that branch is, but of course there are sequences. You don't just merge into your main code. If you're doing a collaborative setup, usually here, this is a single setup, so I directly commit to main. But you find if you're collaborating, you can set a PR, that PR is reviewed, you're told to maybe fix that certain things. But also here, you want the actions to be set in such a way that, let me say if it's from a branch, it has to be thoroughly checked out before you actually so usually that bit is before the merging. So that is where that bit of the PR cannot be merged directly, so it has to be reviewed. And when that is done, of course, the action is able to run. So when I commit these changes, like I said, the job is saying on pushing this, you go under actions, and you're able to see if you can check and see what is happening here. So this is the job that it's running of deploying. So it checks out the code, so you can see it's still at that point. And like I said, it has died. But ideally, when you make a certain change, so here you can actually troubleshoot and see the issue of so SSH and Nginx. So probably there's something wrong with that. Like I said, always looking at the what do they call them, at the logs to try to understand what's going wrong. So they're saying unable to authenticate, attempted methods not supported, so on. But ideally, that would, like I said, it usually dies during the demo, but it would display something like that.
There's always demo fever, but the good thing there was a pre-run. So
Yeah,
guys, it worked. It worked.
yeah, it worked. It worked, but yeah. So this is basically what I had prepared, and maybe let me just show this slide here alongside this action here, so that you can see what the script was doing on there. So here, when we talk about bash, there is let's bring that alongside. Let's get it minimize here. So as you can see, okay, so this is not the script. So let me just see where is that. Yeah, back to the code. And then the workflows, the demo. So here at the bottom, as we talked about grep, so here we're talking about the end of file, as you can see there, and cut and input redirection. So when you have something like this, what is happening is cut. We usually use cut to display information, but what it's doing here is collecting, and then we are inputting that using those tags right there, and it tells Linux to start recording at that point. And when it basically tells you that when you come to end of file here at the bottom, it's where you stop, right? And what that is doing is that it takes all of that. Now, remember, we set it up as a script, and GitHub Actions has accessed the VM, and it's actually making modifications to the index.html. So it actually drops that data in there. And I think that is a thank you. Now, thank you for bearing with me this 1 hour and 27 minutes. A bit of time, but yeah, thank you so much.
Yeah, I would say it's I think thanks so much to our guest speaker, Lawrence. I would really say that, squeezing all these topics, I think you remember when we discussed this previously, it was all about laying out a strategy on how best we can squeeze multiple concepts in within a short time span, right? And I think we really appreciate this. And I think I've been taking some few notes to share, and I think people can see that the presentation is key to setting a foundation for anyone probably wanting to, get to dive in, right? At least this helps you create your learning path, see where you're lacking, see what to explore, so that you can have that deeper dive. And I think our speaker really brought that out. And I think for Linux, let's just, as attendees and everyone out there, let's just dive into more concepts. And I think, yeah, I really like the flow from Linux administration. You looked at the beginner side, the intermediate bit, and the advanced bit. So I think it's all about an individual to assess, okay, where am I lacking? Let me get to dive in, right? Yeah, and when you switch to Bash, you also portray the same concepts around moving from beginner level to intermediate, right? And yeah, I think this is all about all of us assessing and saying, okay, I need to get to learn here and there. Yeah. But also the demos are really insightful, the shift from localhost running locally to cloud, right? Also getting to show people that, okay, what cloud providers also running Linux, right? I think working with all three cloud providers, I could see Azure uses Azure Linux, Amazon uses Amazon Linux, which are just distros of Linux behind the scenes, right? Yeah, and also I think seeing other tools being used, I think as a person who has used Oracle VirtualBox, I am seeing something different. But then also this workshop also shows attendees or shows us that there are more concepts to mastering DevOps, right? Concepts such as Docker, GitHub Actions, we have been seeing that brings into continuous integration and continuous delivery. Then also looking at cloud computing, our speaker showed GCP, but I think for the previous demos, we have been mainly using AWS and Azure. Yeah, today I think GCP got its flowers, but then more concepts like YAML, Ansible, which are really key to, compiling configuration files. I think when you reach to manage, cloud deployments or even local servers, yeah, I would say we really appreciate the preparation. And also you also hinted on cost optimization, which is really important. Also showed budget alerts, how to benchmark your credits. Yeah, I would really say this has really been insightful. Yeah. I think on that note, if you have questions, you can meanwhile leave them in the chat. But I think as this presentation was starting, you noticed that we outlined topics on the poster, and our speakers aim to deliver these topics. And I think one of the core topics I really liked and enjoyed was the hardening, security hardening concepts. And I think Vietnam is milking money out of this because they're selling to you, hardened images which you can use to run secure production ready applications. But luckily, Docker these days introduced, Docker hardened images, DHI. So I would say this introduced a number of concepts, and we believe and we hope it has really delivered a number of concepts for our users. Yeah. Any questions? If you have any questions, you can feel free to put up your hand. I'll unmute you, or you can type in the chat. Yeah. But a big vote of thanks to our speaker, Lawrence. If you can react at least. Yeah, he will be able to see the reactions, and yeah. And I think a vote of thanks to you. We appreciate Lawrence. Thank you for preparing. The people appreciate. Yeah, cooking. I think we already said let him cook. I told Lawrence, I'm waiting for you to cook, and the man has cooked, and this meal is ready. And I think whoever has attended can really say that this has been really insightful. Yeah. About the recording, it will be uploaded on our YouTube channel. Feel free to check it out during the week, and also get to on the Kampala DevOps site, follow all groups. All the communication is always posted there. And if you feel this is beneficial for a friend out there, feel free to share this knowledge, because sharing is caring, right, Dolores? And collaboration. The repos, I see the urge. Yeah.
Definitely.
Yeah, I see the urge of, people wanting to, see these GitHub repo links. Yeah, we're going to add them in the GitHub in the YouTube video upload description. Yeah, but a big vote of thanks to Lawrence. Thank you, thank you, thank you, thank you so much for sparing time, preparing. We hope your Valentine didn't worry about you not giving them focus, because yeah, you were
Easy
cooking.
cooking.
Yeah, but hopefully she understands. Yeah. About the WhatsApp group, Diana, thank you for sharing the link. Yeah, those who can join. Also get to join the LinkedIn group. The LinkedIn group, most of these updates come in with WhatsApp. Sometimes we feel like if you missed out on old updates, you won't see them, but on the LinkedIn group, you can be able to view those old updates. And also, I want to take this chance to also announce that come August, we are holding the Kampala DevOps and Cloud Summit. Yeah, I believe we shall have more speakers. It will be action-packed, a lot to learn. I just want you to keep tabs on our socials. We shall be ready to host you, and yeah, we hope we can have a lively event. We are cooking this, as you know. Lawrence cooked, even the Kampala DevOps team is also cooking. Yeah, and we shall keep cooking, cooking, and cooking till the ends. Yeah. I think with that, let me take this opportunity to say again, thank you so much, Lawrence. We appreciate. Yeah. Uh, there was one. Okay. Thank you so much. Yeah. And without further ado, let's mark this an end. Thank you, ladies and gentlemen. For anything further, we encourage you to go further in, dig in, read, yeah, learn more. Feel free to use the groups, be able to ping questions. To follow Lawrence, you can check him out on LinkedIn. His LinkedIn is active. You can connect personally. Yeah, I know if you send him a ping, he will be able to respond to you. Yeah. And also, in case of anything, reach out to anyone. At least every presenter will bring on board has a LinkedIn profile, or when you go to the Kampala DevOps Community group, you'll be able to ping anyone. Yeah, thank you, ladies and gentlemen. Happy Archbishop General Room Day. Enjoy your public holiday. Hopefully, we sing soon. Bye-bye, ladies and gentlemen. Thank you for sparing your time. Yeah, Lawrence, any final words to say bye to the people?
Just to stay curious and keep learning. The only way to get the people you look at that you admire went through the same baby steps that like you're going through, and just keep practicing. If an opportunity doesn't come your way, just make sure you create one. So you can, with the beauty with AI in Uganda, they said, you can go and send yourself to set up Prometheus and all that, set up Nginx, set up traffic. If it's setting up a VPN, WireGuard, and so on, just keep on going and setting up stuff on your own. The beauty is, like I said, things like Google, you can have, if you don't know what hosting is and how that works, basically keep sending yourself. The more you do that, the better you will become, whether it's even if it's cybersecurity, even if it's infrastructure, if it's anything, just keep on being motivated, being inspired, self-inspire, like watch the right channels. Instead of a Netflix thing, you could push yourself to watch a tutorial about a new technology. There are some new things that come out every week, Hardware Heaven, Learn Linux TV. There are so many channels that are online that have this. I forget, there's one of a particular German gentleman that always, he has a Kubernetes cluster at home, and he runs basically some of his services locally, and you ask yourself, okay, for what purpose? But the guy keeps sending himself all the time to set up such things. So yeah, that's my word to you. And thank you for attending, and thank you for giving me time to listen in.
Yeah. Thank you so much, everyone. Without further ado, yeah, we wrap it up.